Hello students, we were doing vector algebra and we were doing questions related to dot product. क्वेश्चन नंबर 12 कर रहे थे हम, इक्वेशंस तक हो गया था, हमने ये इक्वेशंस बनाई थी। क्वेश्चन में गिवन था वेक्टर a वेक्टर b एंड c वेक्टर गिवन थे। फाइंड द वेक्टर d which is perpendicular to both a and b and d dot c is equals to 21. D is perpendicular to a and b, therefore dot product of d with a is 0 and dot product of d with b is also 0, and it is given that d dot c has value 21. Now we will have to solve these equations. From first equation, find the value of z. So z is 4x plus 5y. Put this value of z in both the equations. X minus 4y, 5 into 3x plus y minus z, 4x plus 5y is equals to 21. X minus 4y, 20x plus 25y, 21x plus 21y, 0. By taking 21 common, we get x plus y 0 or y is equals to minus of x. From here, 3x plus y minus 4x minus 5y minus x minus 4y is equals to 21. Put the value of y here. 3x is 21, so we get the value of x as 7. X is 7. Y is equals to minus 7. Put the value of x and y here. Z is equals to 4 into 7 plus 5 into minus 7. 28 minus 35. So value of z is minus 7. Therefore d vector is equals to xi plus yj cap plus zk cap. So this is the value of vector d. Now the next one, dot product of vector with the vectors 3i cap minus 5k cap, 2i plus 7j cap, I plus j plus k cap are respectively minus 1, 6 and 5. Find the vectors. Let this is vector A, B and C. Let R vector is xi plus yj plus zk. Now we have given that dot product of these vectors with this vector has value this. It means R dot A vector, R dot B and R dot C has value minus 1, 6 and 5. Now first find the value of R dot I. A vector is 3i minus 5k cap. 3x minus 5z is equals to minus 1. R vector dot B vector. B vector has value 2i plus 7j. 2x plus 7y is equals to 6. R vector dot C vector xi plus yj plus zk dot I plus j plus k has value 5. X plus y plus z is 5. These are the three equations. 3x minus 5z equals to minus 1. 2x plus 7y is equals to 6. X plus y plus z is equals to 5. Now solve this equation and this equation. Multiply this equation by 3. 3x plus 3y plus 3z. 5 into 3, 15. 3x minus 5z minus 1. Now subtract these equations. 3y plus 8z is equals to 16. Now solve second equation and third equation. 2x plus 7y is equals to 6. Multiply equation by 2. 2x plus 2y plus 2z is equals to 10. Subtract 2 minus 7 plus 2z. 10 minus 6 is 4. Now multiply this equation by 4. 5 into 4, 4 into 2, 4 into 4. Now this equation is 3y plus 8z is 16. Subtract minus 23y is equals to 0. So the value of y is 0. Now put the value of y in any one of these equations. 3y plus 8z is 16. Put the value of y is 0. So z is 2. Now put the value of y and z in equation 3. X plus y plus z. So x is 5 minus 2, 3. Therefore r vector is 3i cap plus 0j cap plus 2k cap. 3i plus 0j cap plus 2k cap. Show that projection of A vector on B vector. Projection of A vector on B vector is A vector dot B vector upon modulus of B square B vector. Let theta be the angle between A and B vector. This is angle theta, this is B vector and this is A vector. Now in triangle OAL, cos theta is B upon H, OL upon OA, OL upon OA. So OL has value OA cos theta. Now OA is vector, magnitude of vector A, length of vector is magnitude of that vector. Therefore OA is magnitude of vector A. Now we have one formula. A dot B is modulus of A, modulus of B, cos of theta. From here value of cos theta is A dot B upon modulus of A, modulus of B. Now modulus of A we get cancelled, so we get A dot B upon magnitude of vector B. Now if we want to find OL vector, vector OL is equals to length OL into unit vector B. OL has value A dot B upon modulus of B. Unit vector B is equals to B vector upon magnitude of B vector. So that is A dot B OL vector is equals to modulus of B square into question number 14. Here we want to find projection of B vector on A vector, and we have to prove that that is equals to magnitude of A dot B upon magnitude of A square into A vector. You can try it by yourself. This is same as question number 14. The next one is, for any two vectors A vector and B vector, prove that modulus of A plus B whole square is modulus of A square plus B square plus 2A dot B. Second is modulus of A minus B whole square modulus of A square plus B square minus 2A dot B. And modulus of A plus B plus A B whole square plus A minus B whole square 2 times modulus of A square plus modulus of B square, also represented geometrically. थर्ड पार्ट को ज्योमेट्रिकली भी हमें शो करना है. फर्स्ट हम 3 पार्ट सॉल्व करेंगे, आफ्टर दैट द नेक्स्ट पार्ट. In the first part, we want to prove that modulus of sum of two vectors square is equals to this. A plus B whole square, we can write it as A plus B into A plus B. Now take the dot product. A vector dot A vector plus B vector dot A plus A vector dot B plus B vector dot B. A into A is magnitude of A vector square. We know that dot product is commutative. A dot B is equals to B dot A. Therefore, it is 2 times A dot B plus magnitude of B vector square. Now, in the second part, instead of plus sign, here is the negative sign. So, A vector minus B vector dot A vector minus B vector. A dot A minus B dot A minus A dot B minus minus plus B dot B. A dot A is equals to magnitude of A vector square. Again, A dot B and B dot A are equal. Therefore, minus 2 A vector dot B vector plus magnitude of B vector square. First and second part is proved. For third part, add these two equations. What we get? Modulus of A plus B whole square plus modulus of A minus B whole square. Add the right hand terms. 2A dot B plus modulus of B square plus modulus of A square minus 2A dot B plus modulus of B square. This term will get cancelled. So 2 times modulus of A square plus modulus of B square. Now we want to prove it geometrically also. Let ABCD be a parallelogram with vectors adjacent sides A vector and B vector. Now we know that in triangle ABC, by triangle law of vector addition, AB vector plus BC vector is equals to AC. Therefore, A vector plus B vector is equals to AC. By triangle law of vector addition, AB vector plus BC vector is equals to AC vector. Now, AD vector in triangle ATP plus DB vector is equals to AB vector. AD vector is B vector plus DB vector is equals to A vector, or we can say that DB vector is A vector minus B vector. AC vector is sum of these two vectors and DB vector is subtraction of these two vectors. Thus, A plus B vector and A minus B vector are diagonals of the parallelogram whose two adjacent sides are A vector and B vector. Therefore, this condition, therefore this is true. Diagonals of the parallelogram, therefore square of this square plus this square is equals to this, implies that sum of squares of the diagonals of a parallelogram is equal to sum of square of sides of parallelogram. Now fourth part, that is we want to prove is modulus of A vector plus B vector is equals to A vector minus B vector. Implies that A vector is perpendicular to B vector. Fifth part, A vector plus B vector is equals to modulus A plus modulus B. A vector is parallel to B vector. Modulus of A plus B whole square is AB are orthogonal. Now for the fourth part, it is given that modulus of A vector plus B vector is equals to modulus of A vector minus B vector. It is given. Now squaring both sides, modulus of A square plus modulus of B square plus 2A dot B. अभी हमने ये फर्स्ट और सेकंड पार्ट में प्रूव किया था. Modulus of A square plus modulus of B square minus 2A dot B. A square and B square will get cancelled when it goes on left hand side, so it becomes 4 times A dot B, 0. If the dot product of two vectors is 0, then we know that therefore A vector is perpendicular to B vector. Fifth part is modulus of A plus B is equals to modulus of A vector plus B vector. It is given. Now squaring both sides, modulus of A square plus modulus of B square plus 2A vector dot B vector. Modulus of A square plus modulus of B square plus 2 modulus A dot modulus B. Modulus of A square plus modulus of B square, it will get cancelled. Therefore, A dot B, 2 will get cancelled in the next step and we are remaining with this. Now we know that A dot B is, what is the value of A dot B? Modulus A, modulus B, cos of theta. Modulus A, modulus B. It will get cancelled. So cos theta is 1. Cos 0 degree has value 1. Therefore theta is 0. If angle between two vectors is 0, therefore A vector is parallel to B vector. Now for the sixth part, it is given that modulus of A plus B whole square is equals to modulus of A square plus B square. Now we know that this value is equals to modulus of A plus B, A square plus B square 2A dot B. Orthogonal means we have to prove that these vectors are perpendicular. This will get cancelled. So 2A dot B is 0. Dot product perpendicular, or we can say that A vector and B vector are orthogonal. Now the next one, if two vectors A vector and B vector are such that magnitude of A vector is 2, B vector is 1, A dot B is 1, find 3A vector minus 5B vector dot 2A vector plus 7B vector. Now we have to find the value of this dot product. Let us solve. 3 into 2, 6. A vector dot A vector, 7 into 3, 21 A dot B, minus 10 B dot A, minus 7 into 5, 35 B dot B. A dot A, modulus of A square. In the dot product, A dot B is equals to B dot A. Therefore, it becomes 12, 21 minus 10, 11. A vector dot B vector minus 35 modulus of B vector square. Now magnitude of vector A is 2, so 2 square. A dot B has value 1, modulus of B 1 square is 1. 6 into 4, 24 plus 11 minus 35. 35 minus 35, so value of this term is 0.